Today's video starts on page 21 of your packet. It's the problem of the day question. Graph this system of equations on the coordinate grid below. I would like you to use m equals, for instance, 1/2 and b equals 4. That's the first equation. So I want you to graph using slope-intercept form and answer the questions for the first one. The second one, again, I want you to solve them for y equals, and then tell me m equals and b equals. So don't forget that. For each equation, graph them using slope-intercept. And this solution is very hard to see because it's not exactly where two lines of the graph paper meet. So I just want you to tell me, does it have a solution or no solution or infinitely many solutions? And then the last example on the problem of the day, solve this system by graphing again. Solve for y equals, and then tell me m equals and b equals for each of the equations. What do you notice about these equations? And therefore the solution is, and give me the answer to that question. So pause the video, do the problem of the day, 3 problems, and then we'll go on. We'll go over those in class tomorrow. Well, this is really more than method 2 because so far we've made the table, we've graphed, we've used elimination. So this is the second method of solving systems algebraically. So this is method 2 for the algebraic solution. And yes, this is 5.2 in your textbook, the 8th grade textbook, chapter 5, section 2. I'm going to let you read page 23 on your own. It goes through the bar modeling of how x plus y equals 8 and x plus 2y equals 10. And you solve them and you get y equals 2 and x equals 6. You've seen this bar model before in another packet. You could read through that page. So on to page 24. You can solve this system of equations using the same approach but doing it algebraically. So use equation 1 to express it in terms of y. This is called the substitution method. So equation 1, solve it for y, or solve it for x. Express x in terms of y. So we're solving it for x. X equals. So subtracting y on both sides, you can see here you get x equals 8 minus y. They're calling that equation 3. Now put that value of x into, or substitute it into, the second equation that you had there, x plus 2y equals 10. So I'm saying x is equal to that 8 minus y. So put that in for what used to be x. So now I have my equation in one variable. 8 minus y plus 2 more y's equals 10, the second equation. And simplifying it, negative y plus 2y gives you just a y. So 8 plus what equals 10. Subtracting 8 on both sides, you get y equals 2. Then substitute y equals 2 into one of the equations, or the equation 3 that you got, x equals 8 minus y. I wouldn't always go to equation 3. I would go back up to equation 1 if I was you, in case you made a mistake solving for x. You don't want to put your answer that you got y equals 2 in case you've made a mistake. So I always go to the original equations, x plus y equals 8. So I don't agree with this. So I know that if y is 2, well, then x has to be 6. So my solution is 6, 2. The elimination method and the substitution method will, of course, give you the same result. The system of equations is going to have one unique solution, if it has one unique solution. So this method, called the substitution method, consists of 3 steps. Select one of the equations, the easiest one to get one of the variables one variable in terms of the other variables. So solve for x equals or solve for y equals, whichever one's easier. Substitute that new equation, that value of x or y, into the other equation that you first started with to find the value of one of the variables. Then solve for the other variable x or y that you have not solved for. Next page. So here's some practice that we're going to do together. Solve the systems of linear equations by using the substitution method. Oh, well, the second equation already is y equals. So this y is going to go right there into that equation. I'm going to substitute in what y equals. Well, y equals 4x minus 7. So 2x plus my y, which I'm saying is 4x minus 7, has to equal 5. Combine like terms, you get 6x minus 7 equals 5. Adding 7 to both sides, you get 6x equals 12. Dividing by 6, you get x equals 2. Now I'm going to put that x into the second equation, y equals 4 times x, which I say is 2, minus 7. Well, 8 minus 7 is 1, so y equals 1. So my solution is 2, 1. But I better be sure. Let me check in the other equation. Is 1 equal to 8 minus 7? Yes. And 2 times 2 plus 1. Oh, 4 plus 1 does equal 5. Yep. So it does check in both equations. Now I know that the solution is 2, 1. Oh, this would be a better one to eliminate, but it says you have to do it using substitution. So I'm going to solve this top equation for y equals. So the first thing that I need to do is move the 3x over, because I don't want that with my y equals. Careful, careful, careful. That's negative y would equal negative 3x plus 8. Well, multiplying every term by negative 1 or dividing every term by negative 1, this equation becomes all their opposites, and you get y equals 3x minus 8. Y equals, so this expression is going to go where that y is. So 2x plus 3 times, oh, my y is 3x minus 8, oh, I'm going to have to distribute, equals 9. This definitely would be an easier problem to eliminate rather than substitute, but we have to do what it says using substitution. So we get 2x plus 9x minus 24 equals 9. Combining like terms, I get 11x. Negative 24 equals 9. I'm going to add 24 to both sides. And I get 11x equals 33. Well, that's nice. Dividing by 11, I get x equals 3. So x equals 3. Now I've got to figure out what my y is. I'm going to put that into my first equation, which seems pretty easy. Minus some y equals 9, or equals 8. Whoops, I'm thinking 9 here. 3 times 3 is 9. 9 take away 1 is 8, right? So I'm going to get 9 take away 1, so I know y equals 1. So x is 3 and y is 1. Well, let me be sure. I'm going to put it into the second equation. 2 times 3 plus 3 times 1 equals 9. 6 plus 3, yep, 6 plus 3 is 9. So that does check. So my solution is 3, 1. Number 10. Oof, I'm going to have fractions everywhere. This again would be an easier one to do elimination. I'm going to solve this top equation for n. So 2n, and I'm going to subtract that 7m right away. So negative 7m Oh, minus 8, give myself space. So I'm going to have negative 7m's minus 8. I'm going to divide by 2, divide by 2, divide by 2, and I get n equals negative 7/2 of m minus 4. So I'm going to take this n and put it into this expression, or that equation rather. So 2m equals 3 times the quantity, negative 7/2 m. So everything's in terms of m. I only have one variable, minus 13. Okay, 2m equals, well, I'm just going to leave it improper, negative 21/2 m. I'm distributing my 3. Minus 12, minus 13. I'm going to combine my like terms to get negative 25. So negative 21/2 m, negative 25, they equal 2m. I'm going to add 21/2, that's right, add 21/2 m to both sides. Well, 2m's is the same thing as 4/2, so 4/2 and 21/2 is 25/2 m equals negative 25. Well, isn't that nice? So I'm going to multiply by the multiplicative inverse, 2/25. Well, those are going to cancel, not that negative, however. And I get m equals negative 2. M equals negative 2. I'm going to put that back into the first equation. 7 times negative 2 plus 2n's equals negative 8. That's negative 14 plus 2n's equals negative 8. I'm going to add 14 to both sides to get my n alone. And I have 2n equals 6. Dividing by 2, n equals 3. So I believe the solution is m is negative 2 and n is 3. I'm going to put that into the second equation. So 2 times negative 2, does that equal 3 times 3 minus 13? Well, this is negative 4. 9 minus 13, oh, that's negative 4. Yes, it checks. So I know my solution is, I can be guaranteed that it's negative 2, 3. And that's it for today's video.